go. Okay, so literal equations 2-5 was probably the one that people like complained about the most because literal equations are a little tricky, right? You have more letters than you're used to. So take a look at this first one. If I want to solve for x, what's my first move?
Subtract the 12.
Plus 12.
Add the 12, right?
Yeah.
It's a negative 12 right now, minus 12. So add it, it becomes 0. But whatever you do to one side, you got to do to the other. So add 12. So you have y plus 12 equals 3x. How do you get x by itself? Divide by 3. Okay, so your options are this. You could call this x equals y plus 12 over 3 and just leave it like that. Or if you're real fancy and you want to simplify a little further, you could make it y over 3 plus 12 over 3. What's 12 over 3? 4. So you could make it x equals y over 3 plus 4. I don't need you to go this far. I'm good with you stopping at that first one, y plus 12 over 3. But if you want to fancy it up a bit, you would do the second. Okay. Okay, how do you solve? I'm going to skip number 2 because number 2 is pretty basic.
What do you mean it's pretty basic? It's all letters.
That entire word.
Oh, you guys. Look, you absolutely do. Listen to me. This is not hard. You know how to do this. You just did it for me on the last one. If you're solving for W, hey, if you're trying to get W by itself, then you need to get rid of the L, right? How do you do that?
Divide by L.
You divide by L because right now you're multiplying. We do inverse operations. Do the opposite. Whatever you do to one side, you got to do to the other. L over L is 1, so W equals A over L. So it's just one step. That's all you got to do. Okay, think of it this way. Think of it this way. Listen. If A equals 2 times W, and I tell you to solve for W, you divide by 2, right?
Yeah.
This is no different. L is a placeholder for some number, okay? So right now we're saying L times W. I want to get L out of there. So instead of dividing by a 2, we're just dividing by an L, right? Oh, you can use stuff like this all the time.
Dividing letters? Yes.
Yeah, because here's the thing. If I'm trying to work out a problem where I need to figure out like what are the best dimensions for this box that I'm building in my backyard, for my garden box, what are the best dimensions, right? If I set it up with like perimeter or area or whatever, just a basic formula, if you isolate the variable that you're unsure about, then when you go to solve it for different possibilities, it goes really fast. Whereas if you don't, then you have to do all the algebra every time you put in a new possibility. That's why we solve for some specific variable that you could then plug it into the same formula over and over and over in one step. So it is helpful, I promise. Look at number 5. Okay, you're going to solve for W. So we're going to try to get W by itself. This one is probably the trickiest one, I think. You can disagree with me. Think of it as if there are numbers here, okay? If this was 2W minus 6W equals 10, what would your first step be in solving that setup?
Add the like term.
Combine like terms. So we would do 2 minus 6. Okay, now translate that to variables. If this is your setup, what's the first thing you should do? A minus B, right? A minus B, yeah, it's the reverse of the distributive property, right? So we would subtract the coefficients to our W and then multiply by that W, right? If I did this top one, 2W minus 6W is a negative 4, but I'm still multiplying that by W. So because I don't know what A and B are, I subtract them, but I still multiply by the W. Does that make sense? Okay, we'll do another one. So right now we're here. How do I get W by itself? Divide by A minus B. Divide by A minus B. So this is 1, A minus B over A minus B. So I have W on the left, and then I have D over A minus B on the right, and then you're done. Okay, as soon as you get the variable they want by itself, you're done. There are a lot of letters. Yeah.
Is there gonna be one like that on the cat?
Potentially. There can be. Okay, look at this one. Solve for t. Now notice, these are not the same. That's not t and t like it was on this one, okay? So if I'm gonna solve for t on this one, what do I do first? You're gonna get that 2r out of there. So plus 2r. So you get 5t. This is 0. So equals 25 plus 2r, or you can go 2r plus 25. That doesn't matter. Addition is commutative. And then divide by 5. And again, you may just leave it like this. Okay, I'm fine with that. Or if you want to simplify it, it would be t equals 25 over 5 is 5. This would be 2r over 5. So if you want to go simpler, do this one. I am totally fine with you just leaving it as the first one. Okay. Okay, jump down to the next step. We'll go back to some of those if you're still struggling in a little bit, but I want to make sure we cover a little bit of everything. Unit conversions. If I say 15 days and I want to convert that to hours, you start with your original thing, and then you multiply by some conversion factor. So if we're trying to get rid of days and turn into hours, is there a good conversion factor for days to hours? 24 hours to 1 day. Now, what goes on the bottom here?
1.
The days, right? We want the days to cancel out. So days goes on bottom. 1 day is 24 hours. Okay, and now you can multiply. So 15 times 24.
Why can't we just multiply 14 times 24?
Well, that's what you're doing.
Well,
That's-
I know, but then why do we have to do all this? Why can't we just do 15 times 24 and then fill in the blank?
Because what if you go the wrong way the next time? What if you're going hours to days the next time? Do you know to divide then?
Yeah.
No.
You guys, I'm totally going to get sick. My ears are plugging up. My scratchy throat.
It's from the senior trip.
It is. Everyone was sick on the senior trip. So that's 360 hours. Here's the deal. I need you to understand the concept, right? So if I want you to give me conversion factors. I want to know that you know why it works the way that it works. So set it up with conversion factors and then multiply and divide where needed. Yes, sir.
Can we just put like 1 day equals 24 hours? And then like.
No, set it up like this. Set it up as a math problem for me. Yeah. Okay. Feet to yards. Let's see. Let's do.
60 on top.
We'll do this. So 60 feet. Okay. Where do your yards go?
On
Yards go on top because feet go on bottom to cancel these guys out. And then what number on top?
1.
1 yard is 3 feet. Okay. So now you multiply across. This is 60 on top, 3 on bottom. So that's 20 yards. Make sense? Okay. Look at number 4. Car 1 drove 408 miles in 6 hours. Car 2 drove 365 miles in 5 hours. Who had the fastest average speed? What do you do? divide. 408 divided by 6. Anyone plug that in? So no then? 408 divided by 6 is 68. 365 divided by 5 is 73. Okay? The question was, who had the fastest average speed? What's your answer?
Car 2.
Car 2 at 73 miles per hour.
We have to write at 73 miles an hour. Can we just write car 2?
I'd prefer you at least label them. So if you're not going to write at 75, then call these miles per hour or 73, so that I can see that you understood. We were talking about a rate there. I'm telling you guys, word problems, you have to over-inform me. You need to tell me all the details. Give me all the details. Okay, let's do number 5. This is $15 per 1 hour, right? That's the starting setup. We want to get to cents per minute. What do you want to do first?
Money.
Money? Okay, so if we're going to do money first, what goes on top and what goes on bottom? Cents goes on top. What goes on bottom? Dollars, right? We're converting dollars and cents. So $1 is how many cents?
100.
You're thinking hours. $1 is 100 cents. Okay, so our dollars have canceled and we're in cents, which is what we want. Now we have to get to minutes. Okay, so now it's a totally separate conversion. Now we're taking hours and converting to minutes. Where do your hours go? Hours go on top so that these cancel out. So minutes on bottom. And what are your numbers? 60 minutes is 1 hour. Okay, so now we're at the units we want, cents per minute. So now you multiply across. So 15 times 100 is 1,500. 60 on bottom. So you go 1,500 divided by 60, and you get 25. What does that mean? 25 cents per minute. Okay, or you can write it like this, 25 cents per minute. Questions on that? Yeah. Okay, let's do number 7. 10 miles per 1 hour, right? 10 miles per hour would look like that. We want feet per second. Who remembers miles to feet? 5280. So where does feet go? Feet goes on top because miles has to go on bottom to cancel out. So 1 mile is 5,280 feet. What do you do next?
Divide.
Not yet.
Oh, is it by 100?
Then I go to like per second.
Right now we're at feet per hour. We got to go to seconds, right? How do you get from hours to seconds?
Wait, is it 1 to 60?
Is it what?
Is it 1 to 60 or is it 60?
Good question. So if hours is on bottom and we're trying to cancel out the hours, where does the hours go?
On top.
Hours has to go on top.
And 60 minutes.
So 1 hour is 60 minutes, but we want to get to seconds.
And 1 minute is 60 seconds.
Right, so minutes on top, right? Our hours canceled here. Now our minutes are going to cancel here. 1 minute is 60 seconds. So now we're in the units we want. Feet per second. What do you do?
Multiply.
Straight across, right? So you would get 52800, 10 times 5280, over 60 times 60, so 3,600, and then just divide that. Oops, 52800 divided by 3,600 is 14.6 repeating. How many feet per second is she running? We'll say
About
15.
about 14. I'm rounding to the nearest tenth, but yes, about 15 feet per second. Okay, I did 14.7, just rounding to a different place. If I don't tell you to where to round, then I won't be picky about where you round. If you round somewhere different than me.
The slash sign is per.
Per. Mm-hmm. Okay, we're gonna jump to 2. Oh, I don't even have 2.8 on here. It's okay, 2.8 was very similar to this. Look at number 2. Under the 2.7. What do you do here? Cross multiply. 5 times 5 is 25. Negative 3 times y is negative 3y. What do you do next? Divide by a negative 3. So 25 divided by negative 3 is y equals negative 8.3. Here's the deal. When it's a repeating like that, just don't round it. This isn't a real world problem, so leave it like that. Or you could say negative 8 1/3 is perfectly good too. But don't round if it's a real world, not a real world setup. Okay, go to number 5. How do you do number 5? Brody.
Maybe like do maybe like 4 parentheses 2n plus
Right.
parentheses.
Yeah, put parentheses around it and cross multiply. So 4 times 2n plus 1 equals 5 times n plus 2. What's your next step?
When you combine the combinables, so I would say, oh, okay.
You already did the next step. Distribute, right? So this is going to be 8n plus 4 equals 5n plus 10. And now we solve. So take away the 5n. And you get 3n. Here, take away the 4. And you get 3n equals 6. And then divide by 3. So n is 2. Okay.
Are we just submitting what we did in class?
Yeah. Okay, go to 2.9. Here's a quick refresher. Percent over what?
100.
Percent over 100 equals
is over of.
is over of. Okay, and I think most of you liked that way, so we'll try to set it up that way. Look at number 1. What percent? So what are you putting in place of our percent? X. Over 100. What's your is? 28 over 42. And then how do you solve that?
42x equals.
Right. Cross multiply. 42x equals 2800 and divide by 42. And you get x equals 66.6 repeating. That's a percent. So you may write it like that, or 66 2/3%. Either one. So the rest of these I'm not going to solve with you because you guys know how to cross multiply at this point, right? Hopefully. But we'll set a few of them up. How do you set up 3? What over what equals what over what?
X over 100.
75. We know the percent this time. Over 100.
X over 180.
X over 180 is over of. Okay, how about number 4? How do you set that one up?
40% over 100
40 over 100.
X over
equals x
7.
over 7.
X over 720. How about number 5? 60
Over 100.
over 100.
75 over X.
75 is your is. Of is what you're solving for. Okay. Questions on those? Okay. Turn that in like that.
Yes.
Okay.